Hello everyone, and thank you for joining us today for this webinar, Lesson Learned for Reducing Risk in Product Development. My name is Marie, and I will be the host for the webinar. So before we dive into the content, I have a few housekeeping items to share with you. So first, at the bottom of your screen are multiple application tools that you can use, but most of them are already displayed on your desktop. All those application tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. If you think that the slides or the demo area is a bit too small, you can expand your presentation area using your pointer, or also you can also maximize it to full screen by clicking on the arrows in the top right corner. If you happen to have any issues with your audio or your video, you can find some answers in the help widget located at the bottom of your screen. Please note that next to the presentation area, we have a resource list available for you. You will find a copy of today's slide deck, links to resources around the topic of the discussion. So have a look and download everything that you may find useful. For those who want to rewatch the presentation or share it maybe with a colleague, the webinar will be recorded and sent to the email that you registered with within 24 hours. And lastly, if you have any questions during the presentation, feel free to use the Q&A widget. We are here to answer you live via the chat, so don't hesitate to reach out. And in case we went out of time or we didn't manage to answer you, we'll make sure to follow up later by email. Now, I'm going to quickly introduce our speaker. Today, the webinar will be presented by Camille Lewis, who is a former chief system engineer with 20+ years of experience in complex product development, especially in the defense and aerospace industry. And he's now senior consultant in Jama software, helping our customers to get the most out of the platform. So Camille, the floor is yours. I will hand it over to you.
Thanks, Maria, appreciate it. Today's agenda covers a deep dive into the critical challenges to reduce the risk in product development. What are the viable solutions to this problem? Key takeaways, and wrapping up with a question and answer session at the end of the webinar. Let's get right into it. What are the main critical challenges that product development teams are facing? In my experience, the main factors that lead to adverse product outcomes and risk are, number one, no upfront and iterative collaboration during the requirements and design creation and review stages, due to limited customer and cross-functional team involvement in the review and approval of requirements. This lack of cooperation results in missed and misunderstood requirements, driving the product design into severely costly errors later on. Second factor, no digital thread connecting the product and team to the end-to-end product lifecycle process. What do I mean by the digital thread? A digital thread is a data-driven architecture that links together information generated from across the product lifecycle and is envisioned to be the primary and authoritative data and communication platform for a company's product at any instance in time. Without this digital thread, there's no ability to track the life of a requirement through development, test, and release. This missing digital thread results in static requirement documents, rarely viewed by critical stakeholders, maintained in Word, Excel, or a standalone tool used only by a few as a repository. I've personally experienced this at companies where only the systems engineers were accessing the repository, and the rest of the product development team, from product managers down to test and integration engineers, never accessed it. You can only imagine how this turned out. Countless rework during test and integration, in addition to post-launch rework additionally, which was severely costly to the customer and left them very unhappy. So lacking this digital thread leads to no management visibility into crucial metrics for the end-to-end process and no identification of process risk patterns, such as delays in development, multiple test failures, rework cycles, etc. Third main factor is having a low level of requirements management maturity. Let's discuss this in more detail. Level 0, there are no formal requirements, so no documentation exists for user or system requirements. Instead, development operates off of user stories with no clear distinction between the functionality of the system being built and expected user experience. Level 1, document-based requirements. Static requirement documents are created and most often maintained by each author on their desktop with various emails, Slack comments containing more information. This especially gets fun when you have to merge 10 different versions of the same document from 10 different people, from 10 different timeframes, none of which have visibility to each other's feedback in real time. I've seen this at several companies where they lose technical product proposals due to this inefficiency of being able to get a proposal out in time representing the right design specifications of their product. Level 2, siloed requirements tool. A standalone tool in place to draft, review, track comments, version, and store static requirements documents. Compliance gaps, limited reuse, defects, and recalls. Level 3, system-based compliance. Compliance is the forcing function to shift from static to live traceability to meet standards for requirement validation, verification, and traceability into a single end-to-end system. Level 4, product risk reduction. A process-centric focus to reduce the likelihood of all forms of product risk via a system-enabled live traceability. This requires detection and alerts for specification and functional changes, process exceptions, and test failures with resulting impact analysis. The risks mitigated include failure to meet the needs of the customer, failure to perform specific functions, delays, cost overruns, defects, compliance and regulatory gaps, delays, and fines, in addition to recalls. And the last level of maturity, level 5, development process improvement, moving past compliance and risk into the spirit of standard based on quality management and process control. These stages place focus on measuring, managing, and improving the product development process. The unintended result of this fragmented process is that critical functions such as requirement, traceability, verification, validation, risk mitigation, product integration, and compliance are often fraught with information gaps, defects, delays, reworks, recalls, missed requirements, and significant manual effort. This includes all areas of the complex product, system, and software delivery lifecycle that can experience negative outcomes and should be actively managed to reduce the likelihood of occurrence, such as performance. The product fails to perform specific functions. From a quality perspective, product defects are discovered by the customer post-launch. Delays, product ends up being released after deadlines. Fit to requirements, the product fails to meet the needs of the customer. Compliance gaps, gaps identified too late and require extreme costs to rework and fix. And the final, regulatory action, where the product is not approved for launch or recalled post-launch from a regulatory authority. So in summary, product development processes end up with disconnected people, process, and tools. The information is left static and siloed. Thus, your team is always being reactive instead of proactive. There are various product development models adopted today. Let's talk about what I think is the core one embedded in all others. The V model summarizes the main steps to be taken in conjunction with the corresponding deliverables within a system validation framework or product lifecycle development. It describes the activities to be performed and the results that it must be produced during a product development. Fundamental phases are needs analysis, which includes risk assessment, requirements definition, system design, implementation, integration, verification, and lastly, validation.